There's this beautiful bird in the Australian rainforest that can make an entire flock of birds think another predator is coming. And it does it by becoming itself an entire flock of birds. How does it do it? Well, it produces at the same time, simultaneously, alarm calls of many different species of birds, overlapping, panicked, and it can even mimic the sound of wings beating. And real birds believe it. When researchers played recordings of this insane performance out in the wild, the surrounding birds who heard the noises responded like they would to an actual mob of birds. This very special bird does this at a very strategic time when it's about to mate. The bird's called the superb lyrebird, and scientists are starting to admit that it's not actually mimicking anything like a mockingbird would. It's actually doing something closer to composing music, which raises a question for me when I'm sitting outside somewhere, kind of in my head and listening at the same time. Did we really invent music, or did we just find it? In 2022, researchers at Western Sydney University and Cornell published a study in what they call the Proceedings of the Royal Society B. Wow, that's a lot of words. They'd been analyzing the structure of Albert's lyrebird songs. Now, that's a different species than the superb lyrebird. Anyway, these Albert's lyrebirds were behaving as though they were sequencing sounds from their environment. Not just collecting or learning different noises, but they were figuring out how to put them together strategically. I think this is amazing. It's like a producer pulling samples. This bird will put specific sounds together in a specific order, then share that arrangement with neighboring males who learn and reproduce the same sequences. And these sequences are not random. These birds seem to be ordering samples to maximize their contrast. Each copied sound as acoustically different from the last one as it could possibly be. It's like they're showing off on purpose. Now, we all assumed before these studies that lyrebirds were just really sophisticated recorders, very passive birds. But what research showed was that actual editorial decisions were being made. What to sample, how to arrange it. The lyrebird is a producer and a composer, and it's making choices. There's this story. Now, this is unconfirmed, but it's too weird to not talk about. There was this lyrebird in New South Wales, and it learned the melodies of a flautist. Human music entered this bird's repertoire. It got passed to neighboring birds, like it does, and it spread through the population. A flute-like dialect in a forest that had never heard a flute before, inherited by a bird who had. The scientists that call it unverified, they don't even entirely dismiss it either. And I think that says something. Now, if we go back to the same research team that was studying the Albert's lyrebird, they figured out that this bird's habitat shrinks. As the forest gets cleared away, birds in smaller patches mimic fewer sounds, fewer species, fewer calls. So in a sense, the lyrebird's song is a living record of its ecosystem, and it's temporary. Every species it mimics is a species that it's been listening to. When those species go quiet in the forest, they go quiet in the song too. One researcher described it as the bird was carrying the song inside itself. Kind of poetic. The science of this is really divided on what to call what this lyrebird is actually doing. If you want to stay safe, this is just display behavior constrained by genetics, and calling it composition might be projecting. The other position, the one riskier to reputations, which is actually gaining ground now, is that this bird is definitely making choices. What to sample, when to deploy it, how to arrange it. And these choices get passed down in social learning. The line between mimicking and actually making music isn't holding up like it used to. In 2014, a composer named Emily Doolittle did something that might have been a little obsessive. She took recordings of hermit thrush songs where the birds sing way too fast and way too high for our ears to really process, and she slowed them way down, dropped the pitch a few octaves into a range that was comfortable for human ears, and then she started hearing the overtone series. Then Emily and this other biologist, Tecumseh Fitch, analyzed recordings of 14 of these male hermit thrushes using both linear regression and Bayesian modeling. Now, all this means is that linear regression is taking a look at bird counts and how the loss of habitats work. And Bayesian modeling just calculates the probability of outcomes. So they used this to figure out that around 70% of the notes that these birds sing are mathematical multiples of a single base frequency. They then went ahead and published this in the Proceedings of the National Academy of Sciences. So these birds are singing in real solid multiples, the overtone series, the same mathematical structure that generates your perfect fifth, the perfect fourth, the octave. These intervals that form the skeleton of pretty much every human musical system on the planet. Now let's take a look at this bird's vocal organ. It's called the syrinx. It's not forcing this pitch. The scientists who studied this were able to show that it happens at a neurological level. So the bird is actually actively choosing these intervals. Meanwhile, somewhere out in the Amazon, a bird called the musician wren, it sings in ratios of 1 to 2, 2 to 3, 3 to 4, the octave, the fifth, and the fourth. The same ratios Pythagoras worked out on a vibrating string around 500 BCE, arrived at independently by a bird in a South American rainforest. Now, I'm going to try to be fair about the counter-argument of this. A 2012 study tested this hypothesis. They tested it on the nightingale wren and found out that only 2% were close to harmonic ratios. The hermit thrush and musician wren, they might be remarkable exceptions instead of the rule. Although what I keep coming back to is that if nervous systems separated by 300 million years of evolution keep independently coming back to the same acoustic ratios, the octave, the fifth, the fourth, I think there's something there. It's a pattern that keeps coming back. The intervals come out of the physics of vibrating matter. Any resonant sound, a voice, a wind through the reeds, a vibrating branch, it produces them. Organisms that evolved to process vocal communication would have developed sensitivity to these relationships because they're naturally occurring. What if the preference for these intervals is not cultural? What if it predates our culture and our human society by this crazy, incomprehensible amount of time? The octave and the fifth are not Western constructs. They're properties of actual sound itself. The hermit thrush didn't learn this from us. We both found them. In 2022, the Leis-Meitner Group for Environmental Neuroscience at the Max Planck Institute ran a study. 295 participants randomized 6 minutes of birdsong audio, and people's anxiety dropped. Paranoia dropped. That last one surprised researchers so much they flagged it, because it was the first study to document that birds' songs could actually drop paranoia in people. Higher diversity birdsong, 8 species instead of 2, also reduced depression. Traffic noise worsened that depression as a comparison. In a separate study at King's College London, they tracked 1,300 people through a smartphone app called Urban Mind. Did it 3 times a day. Seeing or hearing birds improved mental well-being, and the effect lasted on these people all day long. It even showed up and helped people who were already diagnosed with depression. And this makes so much sense if you think about it. For most of human evolutionary history, birds singing meant no predators. A silent forest is always a warning, right? The presence of songbirds means there's safety. They go away when there's danger. This has always been real-time communication, information, even for us, by nature. And over history, we've even become wired to interpret birds' songs for clearance. A deep subconscious signal that lowers our threat response before we even register anything. That's why it works through headphones in cities for people who have never spent a day in the wilderness. It's just inherent. The first gene ever linked to human speech, FOXP2, is expressed in the brain of a bird called the zebra finch. The patterns of this gene are very similar to ours. The protein that makes it up is 98% identical between zebra finches and humans. When FOXP2 is suppressed in a baby finch's brain during its critical learning window, the bird can't accurately imitate a song from its parents. It just produces screwed up attempts, which is the same thing that happens in humans with FOXP2 mutations. We share the neural machinery for learned vocalization. It's biology. It's a real connection. Anthropologist Stephen Feld spent years with the Kaluli people of the Bosavi rainforest in Papua New Guinea. He documented what he learned there in his book called Sound and Sentiment, published in 1982. This was a culture's whose entire musical system came from the forest landscape. It's very cool. The Kululi have a concept called Deluguganalan. It translates roughly as lift up over sounding. It describes the layered overlapping texture of rainforest. In other words, there's no sound that exists all by itself. Everything weaves together, creating something bigger, more layered than any individual part. That's both an ecological description and an aesthetic principle to these people. There's sort of a synesthesia here, visual and sound together, and it's how their whole forest sounds and what it is. And so to them, it's how their music is supposed to sound. They don't imitate birds, they join in with them. Their ceremonial Gasalo songs, they use descending melodic patterns that are inspired by the call of what's called the Mooney bird, designed specifically to move people to collective weeping. When Feld showed the Kaluli people photographs of birds, the people's first response was to imitate the sound they made, not describe their appearance or name the birds. In this rainforest, sound is the primary sense. These people's entire taxonomy of birds is organized around what they sound like, not their names or what they look like. Now, on the other side of the planet, Aboriginal Australians developed the song lines, songs that encode navigational, ecological, and mythological knowledge into melodies tied to specific landscapes. Each verse corresponds to a physical feature in the land. A bend in the river, a rise in the mountain, a change in the bird calls. Different people hold different sections of that same song line, their parts fitting together the way parts in a bigger composition fit together. This tradition is so ancient that trying to guess how old it is gets really speculative really quickly. But it's around one of the oldest continuous knowledge systems that we know of on Earth. In ancient Greece, Pythagoras' consonant ratios were not just music theory. We know that. They were physics, cosmology. They were a belief that the same math running through a vibrating string was also running through the entire universe. The Orpheus myth, a musician whose lyre could move stones and persuade the gods of death. In Ovid, the women who dared challenge the muses were transformed into birds, as if the Greeks understood on some level that the birds had prior claim. What's so odd about all this is all of the independent convergences. The Kaluli, the Aboriginal Australians, the ancient Greeks, they all arrived from completely different starting points at the same set of conclusions, that the natural landscape of the earth is organized and it's meaningful and it has patterns, and that music is not something that humans invented, but something humans participate in, and that the birds have always been composers and players. The hermit thrush is singing an overtone series in a canopy somewhere right now, whether anybody's there or not to hear it. The lyrebird is somewhere sequencing its little samples, revising its arrangements, passing songs off to its neighbors. Ecosystems are out there separating frequencies, the same way they've been doing it for millions of years. We didn't invent this orchestra. We heard it a long time ago. And we'll always keep hearing it. In the math that we've built into our music scales, in the myths and stories that we tell each other about birds and gods and music that moved stones, in the way our nervous systems will go very quiet and start to calm down when something starts singing in the trees. The bird outside your window, it's out there right now performing with you.